Hi folks, welcome to a new video on my channel. In today's video we will be doing a communication between this DVP10SX PLC with a DVP16SP module as an add-on card which is fitted to this PLC. We will be communicating this DVP10SX to the Delta, the old version Delta, the basic model L series VFD, which is quite old and is almost been phased out by Delta now. So as you can see, the PLC is in the stop stage and the frequency is 60 Hz. The communication between the two is through the RS485 port. Only two connectors. I'm using the RJ13 connector, the normal telephone connector which you get. We can use the same one, and you can use only the 3 and the 4 cable of the RJ13 connector will be required for doing this communication. Okay, so you need not go for the 6 pin RJ connector. You can go for the 4 pin one which is used in the telephone lines, the normal telephone lines which you will get in a normal radio shop. Okay, so this is the RS485 port of the PLC, which is using the signal plus and signal minus connectors for a RS485 connection. Okay, so as you can see, I'll just show you the parameters which are very important to set. Okay, we have to go to the communication parameters. Okay, this is the drive address which I have set to D2. Okay, 9.00. This is very important to set the communication address. The rest will remain default, because if we go to the communication parameters, okay, if you can see the 9.00 is the address. Okay, I'm using the default baud rate of D1, which is 9600 7E11. Okay, so that will remain as default 9. You don't have to change all these things if you are because the factory setting is D1. I'll just show you on the see, the default setting is D1. Okay, so this you don't have to play with. Only thing, the address you will have to set, and based on this based on this address, this D2 is the command. You'll have to input the same address in the modREAD command, which I'll be showing in the video later on. Okay, so the other thing which you need to do is you need to change these parameters, this operation method parameters. Okay, so 2.00 you have to change to D4 source of, because we'll be changing the frequency as well as the operation, I mean start and stop. Okay, and 2.01, 2.00 and 2.01 I'll be changing it to 4. Okay, both are RS. I'll just show you the setting here. So 2.00 is 4. Okay, as I've shown you, and 2.01 is also okay, so that is 3. So what I've done is you can also set it to 4, because it doesn't matter. 2.01 is this, D3 is the, so keypad stop is enabled. Okay, but I'll not be using any keypad stop here. Okay, yeah, so once you do these settings, So you just have to go back and okay, now we'll go to the program. So we have got a beautiful software which I was using WPLSoft, but now Delta has also come up with the ISPSoft, and this software is in line with the latest developments in the PLC world. You get a block kind of a diagram here, so it is very easy to understand how to do the programming. Okay, so to communicate between the laptop and the PLC, and to see what's really happening in the Delta PLC and give control inputs from the laptop through the ladder diagram, I'm using the Delta proprietary cable, which is quite expensive by the way, and I've connected it to the RS485 port of the PLC. Okay, so now coming back to the program, so here we have this okay, to make the initial connection we will require this connection manager, COM manager from Delta. So you'll have to create a connection by doing a add and okay, selecting the COM port and doing a auto detect. Okay, now I'll just show you for the existing one which I have. Okay, so since it's already running, it is the same as this. You just go here and you select a particular COM port. Okay, now mine is a COM 5 UART, USB to UART, and you just say okay and auto detect, and it will take the settings automatically. Okay, so this is the way, and then what you do is you go here and you can also access those communication settings here. Okay, now it is already in the online mode. Through this icon we can go to the online mode, so it's now already in the online mode, so you're not able to see the communication settings here because it's already in the online mode and it's communicating. As you can see, the RS485 light is continuously blinking on the PLC. Okay, so I'll just explain the program in brief. This is M1002 is a bit which starts when is initiated when the PLC starts. Okay, in the ISPSoft, to input any hex value, you will have to prefix it with a 16 hash 16 hash prefix. Okay, so my communication is 9607 even 1. Okay, so for that the communication string works out to hex 86. Okay, though that hex string we'll have to store in data register 1120 first. Then we'll have to set the register 1120 for RS communication, for RS485 communication COM port 2. This we are telling the PLC that we are using this port for this communication. Okay, the next step is the timeout value which we are moving. We are moving a value of 1 second, 10 seconds to this D1129. After that we have a 1143 which is used to give an ASCII, indicate that we are doing an ASCII communication by doing a reset of that bit. Okay, then it is just a reset timeout. If there is a reset timeout, then we set of if the M1129 is set because of receiving timeout, then we are just going to reset it again. Same thing with the modREAD or modWrite operation. Okay, bit, and yeah, so before sending, now I'm using this bit M2 as a trigger bit for starting the VFD. Okay, so before passing a modREAD command, we have to initiate a send request signal through by setting the M1122 register. Okay, so when I raise a give a trigger, it will set this M1122 register. Okay, and after that when then we have this M2, which is a load input which we are giving, and through which we are initiating a modWrite operation, okay, to start the VFD. Now S1 is the address. If you remember, we had put the address as in the communication parameters of the VFD, that is the D2. Okay, so modWrite S1 actually uh, is the address of the VFD station address, we call it, and 2000 is the address value where we have to write modWrite in for starting the VFD. Okay, and 2 is the value of the command. For 2 means we are starting the VFD, we have to use 2. This is predefined by delta. Okay, I'll just show you that. Okay, so this is the address, station address, which I was talking about. I have put it as D2. Okay, this is parameters 9.00. Okay, now if you go down, so actually this is the these are the 2 pins which are important for communication between the PLC and the VFD for RS485. This is pin number 3 and 4, SG minus and plus, which I was talking about. I just found it, so I just thought I'll show it to you people. Now we go down, we go to page number 60. Here it is. Now if you see 2000, so these are the commands which have been defined by delta for doing all kinds of Modbus operations. So these are the addresses. 2000 is the address. Now for running, we have to give 2, command number 002, and to stop it is 1. Okay, so that is the way it is used. For forward operation, it is again bit number 4 and 5 should be 1. So this is how the the addresses are to be written. Okay, so that is what I mean by when I say I have to select, I have to input the value 2 in 2000 to start the VFD. Okay, and once it is started, I'm resetting the bit data register M2, not data register, or the register M2, which is a flag register. Okay, now for stopping, I'm using the flag M1, flag register M1, and it is the same process. Only thing, while writing in 2000 the hex address, I'm writing 1. Okay, and this is the address of the VFD. Okay, now I'll just show you this operation of start and stop. Okay, by which you'll come to know now, as you can see, the VFD is already in the stop position. As you can see that the LED is glowing here. Okay, now what I'll do is I'll go over here. It is already in the online mode. As you can see, that is the RS485 port is blinking, RS232 port is blinking. So what I'll do is I'll go here. So okay, one more thing, you don't, even if this port is not blinking, the RS485, doesn't mean that there is no communication. Okay, already there is a communication happening. Only during the data travel and when there is a send, when the PLC is sending the data or receiving data from the VFD, only that time this RS485 light will blink. Okay, so it is not that your communication is not happening if the light is not blinking. It will only blink when the data is being transferred. That's the point. Okay, so what I'll do is over here, I will do a positive edge trigger to start the VFD. Okay, so I'll do a rising edge trigger. Okay, as you can see, the VFD is started because the run LED is coming on. Okay, now what I'll do is I'll go down and I'll do a stop operation. So I'll go over here and I'll do a, sorry, I have to click this particular, and I'll say rising edge trigger. Okay, so immediately we can see that the PLC has, the VFD has stopped. So for decreasing the speed, I'm having another program over here, where there's a flag which I'm setting M3, which will fire a timer. Now this timer will again it's a 1 second timer, so that 1 second timer will fire another bit M5. So M5 will do the modREAD operation by initiating a sending request M1122, setting the flag M1122. Then it will again initiate a modREAD command on the address 2102. Now 2102 is the address of the VFD, which will read the existing frequency which is set in the VFD, and it will store in the register 1050. Okay, now why I'm doing is because I'm taking a dynamic value which is already set in the VFD and reducing it by 1. So that is the reason why I'm doing a subtract operation also based on another timer which is fired with the same flag bit of M5. Okay, once that frequency is taken, we will do a subtract operation, and then that value after that will be triggering another bit M7, which will do a, we'll just go to M7, which will do a modREAD operation on of D1 to the value 2001, which is used for setting the frequency of the new frequency of the drive, that will be 60 minus 1 Hertz, so 5900 Hertz. So now I will just show you how it will work. So as you can see, now the frequency on the drive is 60 Hertz and it is in the run position. So now let me change the frequency in the run position itself. So I go over here and I say set this bit as on, okay, for some time, and I put it as off. Okay, so maybe it has gone twice, 2 seconds it is already. So if you go down, you can see the value of D is now 5800. Okay, so 5700 is the new value of D1. Okay, and that value has been, I think we have to go to M7 to see what value has been written. So 5700 has been written to the VFD. So we'll just verify that. So as you can see, it is 57 Hertz over here. Okay, so same thing we are doing with the increase frequency command. Okay, we will go to increase speed. So I'll just set it on. Okay, for a second I'll set it on and I'll just set it off again. Okay, so now what we can see is the new frequency which has come over here is 5800. Okay, and we'll see what has been set. Sorry, where it is on. So 59 is the new value, 59 Hertz. So we will just watch over here. So again you can see that the 59 Hertz has been set. Okay, so that's all, folks. So I just wanted to show you this basic operation because I have not got any in detail depth videos of this kind of delta VFD and L series VFD and a PLC communication, and you can do a simple 2-wire operation to have the communication done. Okay, so another thing again I want to point out is, even though this particular RS485 light is not glowing, it doesn't mean that your communication is not happening. It does happen when the data is sent and received. Okay, so I hope you like this video, and if you are having any queries, you can always come back to me on comments and I will be happy to answer your queries on comments. Okay, so please do share and like my video if you are happy with the videos, and do give your support to the channel. Thank you.